Hello everyone. It's October 25, 2025, a lovely Saturday. This is your host, Sam Nokani, and today I'm super excited to introduce a trending article from the archive that's, like, totally mind-blowing. Alright, let's dive right in. The title of today's paper is GMFVAD, using Grained Multi-modal Feature to improve video anomaly detection. New. Whoa, that's a mouthful, isn't it? GMFVAD. It sounds like a super cool secret code name for a robot. And if you're curious, you can find it on our site. Mike. Tutorial is at Siverxiv. ID 20,268 phone. Yeah, it's a bit long. So, what is this paper all about? Basically, it's trying to solve a really important problem called Video Anomaly Detection, or VAD for short. Imagine you're a security guard. It's almost impossible to catch everything right. VAD is about creating a super smart AI that can watch all those videos for you and automatically point out when something weird or abnormal happens, like a car crash, a fight, or maybe even a fire. But this is a really tough challenge for computers. One of the biggest hurdles is training the AI to teach it what's weird. You'd ideally have to go through thousands of hours of video and label every single second as normal or abnormal. That would take forever and cost a ton of money. So, a lot of researchers use something called weakly supervised learning. This means they just label the entire video. Like, this whole horror video has a car accident in it somewhere, but they don't say exactly when it happens. It's like telling your friend there's a surprise in a book, but not telling them the page number. It makes the Justin's job way harder. Now, previous AI models tried to solve this by just looking at the video frames. But sometimes, that's not enough. More recently, some cool new methods started using text descriptions along with the video, which is called a multimodal approach. Because text can explain things that are hard to see. But this paper points out a big problem. These older methods just kind of mash the video and text information together in a really unclose way. They don't think about all the boring, repetitive stuff in a video. Imagine a security camera pointed at an empty hallway. Like 99% of a video is just an empty hallway. This is what the paper calls redundant information. All that boring data can act like noise and make it super hard for the AI to focus on 1 second when something actually happens. So what's the awesome solution from this paper? It's all in the name, GMFVAD. The main idea is to get way more detailed or grained with how it uses both video and text to filter out all that boring, redundant info. It's a super clever two-step process. First, for the video part, it uses something called a glance of force network. This is so cool because it works just like our eyes. When you walk into a room, you first kind of glance around to get the general vibe, right? Then, if something catches your eye, you focus on it. This AI does the same thing. It glances at the whole video to understand what's normal, and then it focuses in on the specific parts that seem important or unusual. This helps it ignore the boring, static background. Second, for the text part, it uses a smart AI called Swingbird to automatically write captions for what's happening in the video. It's like having a little narrator describing the scene, saying things like, a person is walking, or a bag is on the floor, and here's the magic. GUM uses or combines the focused video parts with these text captions. The text gives the AI extra context to understand what it's seeing. This way, it can get rid of visual information that isn't important and really focus on the parts that matter. This new super refined combination is what they call a Grained Multi-modal Feature. It's way smarter because it's not just looking, it's understanding. So how could this amazing tech be used in our daily lives? I've got a few awesome examples for you. First up, the most obvious one is public safety and security. Think about surveillance cameras in big cities or at airports. Instead of a person trying to watch dozens of screens, GMFVAD could be the ultimate sidekick. It could instantly flag a suspicious abandoned bag, detect a sudden crowd panic, or spot a traffic accident the moment it happens. This would allow security or police to respond so much faster, which could seriously save lives. Second, let's think about factories and manufacturing. Assembly lines have tons of robots and machines working all the time. This technology could monitor the production process and detect anomalies that a human might miss. For example, it could spot a tiny defect in a product in the conveyor belt and notice if a machine is vibrating weirdly, which may mean it's about to break down. This could prevent accidents and make factories safer and more efficient. And third, here's a really heartwarming application: smart home systems for elder care. Imagine an elderly person who lives alone. The camera with this technology could learn their daily routine. If they were to suddenly fall and not get back up, the system would recognize this as a highly unusual event, an anomaly. It could then automatically send an alert to their family or to emergency services. It's about using technology to provide care and peace of mind. Now, how does GMFVAD stack up against other technologies? Well, old methods were often unsupervised. They were only trained on normal videos. And the idea was that they would learn what normal looks like so well that anything different would just pop out. The problem is, sometimes they can get confused, and they might not be very good at describing why something is abnormal. Then you have the weakly supervised methods that only use video. They're pretty good, but they can be tricked. For example, imagine a video of people running. Were they running in a marathon, which is normal? Or are they running away from danger, which is an anomaly? Without more context, it's hard for a visual on the AI to tell the difference. That's why multimodal methods like GMFVAD came along, which also use text. But as we talked about, they just mix everything together. GMFVAD is the next evolution. It's smarter because it uses the text to actively clean up and refine the visual data. It's like the difference between just splashing paint on a canvas versus using a fine brush to carefully highlight the important details. GMFVAD is the artist with the fine brush. In conclusion, this paper introduces a really powerful new way to detect anomalies in videos, cleverly combining focused visual information with text descriptions. GMFVAD can cut through the noise and pinpoint the abnormal events with amazing accuracy. And the proof is in the pudding. The paper shows that GMFVAD achieves state-of-the-art performance on several major datasets, which is like getting the highest score in a super difficult exam. Isn't that just incredible? Technology like this is making our world a safer and smarter place. That's all the time we have for today. This was San Noikuni, and I'll see you next time. Bye-bye.